The overall topic is called Adapting to the Smart Era, and it could equally be called Not Adapting to the Smart Era, I guess, because it just depends how far advanced everybody is in their progress through smart technology on their journey. So, do we have anyone in the audience who is already utilising smart technology in their businesses? No? Okay, well, Not Adapting to the Smart Era is probably a better title then. And how many of you think you might be planning something in the foreseeable future? So you don't know by the sound of it. All right, well, hopefully then we'll be on an education path today, and we'll try not to bamboozle you too much with technology, and to try to show you how to introduce smart technology in a manageable way. Nicc Lewis has a very interesting technology about software-based private 5G networks, so he'll tell you all about that and how that can be utilised in. Okay, I'm going to ask the rest of the panel for their perception of that question as well. You know, where do they see the UK, you know, in terms of... So I'll start with Nicc, actually, and get him to comment, because I know you've got quite a lot of international experience.
I was going to cover this in a quick introduction, but you know, I think it's a good time to put it right now. So basically, there's a bit of a dichotomy going on, because the UK government was actually one of the first governments to actually allocate private 5G spectrum, which basically means that the manufacturer actually owns that portion of the bandwidth, which means no one else can have it. But on the second hand, and it really pains me, having been born and bred here, to see Britain so far behind, as far as the adoption's going. So, for example, we see in Taiwan and Germany that they've gone from lab to shop floor with implementations of smart manufacturing, automation, in quite a really heavy way. For example, I can't really mention the name of the manufacturer, but it's an automotive manufacturer in Germany. You can pick whichever one you think it is, who have run an entire plant on a private 5G network that is running cameras, robots, AGVs, all computed on the edge with AI, and that's being rolled out right now as we speak. A factory in Taiwan, same thing, completely automated. With a flexi floor, which means they can move machinery seamlessly from line to line, extend the line, retract the line, whatever they want to do. The good news is that Britain's not as far behind as the US, for example, where the government there is still debating over which bandwidth and how the bandwidth's going to work. So I mean, there is a bit of a broad spectrum that's going on. Yes, far behind a couple of countries. I think the next country that's going to come out even before Britain, on the journey, is France. By the way, it's looking right now. But I think the interest has started. I mean, usually the first questions that people ask is about the tax and the funding and how they can get taxed. So once people are asking about tax, the next question they ask is what they can use the money for. Usually the next question is health and safety before production, which is quite interesting. So we see the first use cases being based around cameras and health and safety, and then moving out into full automation. So I would say that Britain's around 18 months behind right now. It should be the first lab cases coming out like this year.
Very happy to take some questions first.
Sorry, thank you. Yeah, just a general one. We've talked about the UK being behind much of the rest of the world in terms of digital journey. Do we have any thoughts as to why that is? Because surely understanding the why is critical to then trying to help with the catch-up.
I mean, I could answer the question in a very cynical way, which is, why did Britain leave Europe? I mean, there's a number of questions. I think there's an inherent cultural issue about giving up control. I hate to say it, but I'm going to say it as it is, and being able to move on. I think there's a little bit of I don't want to be the rest of Europe. I am British, and I'll do things the British way. Do I think it's wrong? A little bit. Do I think it could have a benefit in the long term? Possibly. You know, the good news is, I mean, as you said, like, you know, when Britain decides it's going to do it, it's going to do it. You know, and it's going to happen. But I think the benefits of it is to actually, like, you know, what we see is like each country that adopts new technologies and smart manufacturing and Industry 4.0 learns from its predecessors as well. So the actual rate of change becomes a lot quicker and a lot smoother. Especially when we, you know, from our perspective, you know, we work on an open community of like private 5G. So we see use cases being developed, like how, you know, you're supposed to connect a camera to the network, and that's already like off the shelf. So you just take it and move. You know, we deploy on Microsoft Azure, so you can deploy our software from the cloud. You know, everything's already been taken into place. So I think there's, you know, although it's a little bit behind, I think the, you know, the potential is much higher. I think the potential is strong.
Thank you. Anyone else want to comment on that?
Yeah, I was going to say, I think maybe there's a tendency not to reach out and broaden horizons. I think found UK manufacturers are very much focused on the day-to-day, getting things done. And actually, one of the comments earlier about the pandemic and some of the positive effects that have come out of that, actually we found that was a chance for manufacturers to sort of take a step outside their everyday, think a bit more strategically about how they will move forwards, and, you know, make the decisions to change. So.
Excellent. Thank you.
Yeah,
Yes,
I think just
Phil.
to echo what the guys have said here, you know, I think we are, you know, we're naturally cautious as a nation, and I think we always have been. Other countries have always been open to trying new things and becoming early adopters of technology. You know, if you think about that scenario where there's it sounds like a joke, but it's not. There's a Swede, there's a German, and there's an English guy, and they're all trying something new. When that question comes along, who's going to go first? It will never be the English guy. He will go, no, you go first, and I'll see what you do, and I'll learn from that. And I think, you know, there is an element of that. I think there is also some benefit in being, you know, not going first, and actually looking at what other people are doing, and looking at some of the mistakes and pitfalls that people fall into, and actually course correcting, so that it's far easier for us to roll it out. So sit back, observe, and then do the right thing. So I think that's kind of the way that we operate as a country anyway.
Thank you. Well, the pioneers are always the ones with the arrows in their backs, I think it said, isn't it? Sorry, yes.
I understand what everyone's saying about watching, learning and going better. Not necessarily proof point. If you look at the smart meter rollout that we sat and watched the rest of Europe do and do properly by putting the onus on the network providers to give consistency, we followed on and got it all wrong by putting the onus on the energy suppliers and made a right mess of it. So in that case, one instance of sitting, waiting and watching, definitely not learning from other people, I think. But point taken.
Okay, thank you very much. I can't resist, after all this discussion about Europe, to ask Marcus what he thinks our competitive position compared to Germany might be, and what your sort of perception is.
At first, yeah, Germany is really part of the European Union. That means we can take part on the European regulations and standardization. And therefore, I would say, in general, also there are some standardization committees regarding this direction, for example, smart manufacturing. So I think there are some developments in this direction which are driven from some German companies in the automation business, definitely, yes. And we see also, so I would say it's as it is still part of the European Union, it has a better position because that is an advantage.
Thank you very much for that. I appreciate that. Okay, well, if anyone wants to comment further, otherwise we'll go on to Nick and for your presentation, Nick.
Okay, so I'll try and keep this brief and at ground level. Basically, ASOCS provides private 5G software for management of a private 5G network. Okay, it's an alternative to fiber or to Wi-Fi. to make it as simple as possible. The advantages are based around reliability, performance, and security. Security I spoke about earlier. Basically, everything's on-premise. It's a private network, which means you own your allocation of the bandwidth. None of the data leaves your premise. Everything's done on-premise. When it comes to reliability and performance, the performance of 5G is as good as fiber without having the cables. So everything's completely mobile. So an example of a factory that wants to use a flexi floor where they want to be able to move machinery from one part of the factory to another, seamlessly integrated into a line. It's plausible, it's possible. Now, there's no need to rewire. AGVs, drones, digital twins, AR can all run on a private 5G network because the speeds are so strong and the latency is so low. So you're actually having real-time AI computation happening on-premise at the edge. So you can take a non-smart camera, point it at something, have AI compute whatever you need, and send back a message to another device. Classic example, quality assurance. You have a camera above the line, defect, tells the robot to push the defect off the line. That simple. Another example we've been using is to take things like to a level where people didn't even realize. So when we go through a process with a new factory, we do what we call a simulation workshop, where we sit down with an integrator and the plant manager, and we just talk in general about what they need. And we say, don't limit what you think, but let's start with something small. Let's start with a first case, something that kind of makes sense. Basically, what we would suggest is to start with what we would call a lighthouse project, which is a single project that proves a case and shows the ROI. And based on that, you have the roadmap to go forward and then to expand more and more into what you want to do. It's not change everything overnight. It's let's show you that it works and then go forward from there, step by step.
Thank you.
I'm sure there's lots of questions about 5G and private 5G and lots of conspiracies and about it causing COVID and stuff. But I'm happy to answer any questions. I think it's easier for me to answer questions about private 5G than it is to actually explain it.
Does anyone in the audience want to ask a question about private 5G, or indeed any of the panelists?
I have a question actually. We see a desire of more and more customers to instrument as much of their assets and plant and heavy equipment and capital investments within their organisation to really tap into the data that those things are providing. I'm assuming that instrumenting an asset using 5G is a capability that can be done. My question is, these assets generate stacks and stacks of data. So I'm assuming that the data just goes into somebody's data lake or into their repository or into their data warehouse, and that's not anything that you worry about too much. You just worry about the connectivity and moving the data from A to B. Is that correct?
Firstly, with regard to devices and connectivity to a network, if it's not 5G ready, which a lot of machinery isn't, but it is internet ready in some way, then we can attach what's called a CPE, which then converts it into 5G ready. That's not an issue. Yes, we predominantly only deal with the data connectivity, particularly between the device and the edge for the initial computation, but also like out to the cloud, and into the data lake, and then whatever needs to come back down through, obviously we make sure that it happens as well. But yeah, it's an interesting field in general, because some of the data is real time and some of the data you don't need real time. For the non-real time data, I wouldn't say that 5G is what you really need, or a private 5G. But where you do need mobility and real time data analysis, then 5G has a definite advantage.
Got it. Thank you.
I think there's quite an interesting kind of perception between the two Lewises, if I may put it that way. Whether, you know, you were talking, Phil, about starting with a vision, which is a sort of grand overarching concept, whereas Nicc is talking about, you know, small implementations of solving individual problems. Are they complementary or are they competitive?
I think they're complementary. I mean,
Yeah,
I don't say you shouldn't have an end vision. I think vision is like everything. You know, when you look at the best companies in the world,
yeah.
they always have like a strong vision in place. And but the flip side is to say, okay, now I have this end goal, and I know this is where I want to be in 5-10 years time. Where do I start? You know, and the starting point is that small step. You know, that first win and that first understanding of my ROI. Because you're going to put money, even if you get like 30% of it back on your tax credits, you're still putting money down on the table, and you want to see like where you're going to get that money back. And I think that's important. Welcome to day 3, and congratulations for making it this far. It feels like Squid Games, doesn't it? My name's Nicc Lewis. I'm VP Marketing of ASOCS. We provide private 5G management software. So, I mean, it's not the 5G that you probably know about, like through O2 or EE. It's a fully private network that's held on premise, usually end to end. We provide the vRAN, or what's called the vRAN, the virtualized RAN, the radio access network, where we manage the connection between the devices to the core and then onto the edge where you do the computation. So, to put it in the simple terms, it's if you have a camera and you need to run some AI, we will provide the management software that will enable that camera to link to the network, back to the AI, and then receive the information and send it back to another device, all in real time. Those are the advantages of 5G. I'm sure that there's tons of questions out there, and probably the first one I can tell you is 5G doesn't cause COVID, definitely not private. You don't need to wear any aluminium hats. Like it's a low voltage, low wattage solution that provides a seamless coverage across a plant, indoors and outdoors, all based on a SaaS model. We actually have end-to-end solutions that are available through partners that are end-to-end SaaS. So from the cameras to the virtual edge, all on a subscription base, which means it's easily scalable and easy to enter. I'm happy to answer any questions about 5G and private 5G and how it works. I think it's easier to answer questions than to try and explain the bits and bytes that go into it.
And it was around the idea of what you mentioned with the fear of connectivity and fear this ongoing sort of apprehension to adopt from SMEs and companies where it might be the fact that, you know, open source architecture is something they're scared of, or, you know, what do you do to eliminate this sort of apprehension to adopt networks like 5G in, you know, SME companies and other companies as well?
So let me start by being a little bit controversial. It's a lot worse in Britain than it is anywhere else. Okay? Yeah. The fear is inherent. I don't know what it is, whether it's cultural, whether it's let's wait and see what happens in other countries. But, like, you know, when we look at the deployments we've done elsewhere around the world, the fear's a lot less there. Where the fears come in, there's one on security, where actually private 5G has an advantage because there's no packet core going out to any public service. Everything's held on premise. The entire network's managed on premise, and even the edge server is on premise. So in that case, like anything that is going out to the cloud is not real time, not essential, and can be protected through normal cybersecurity. But the main functioning is happening like on premise. The second one is cost, which, you know, in some cases is true. Like if you're buying a box solution from one of the larger providers, I'm not going to mention names, but, you know, one had an 8110 in the 90s. You basically having to purchase like a large box, you know, and if you want more, you need to purchase another large box and another large box. With the OpenRAN and the ORAN open systems, then you can actually like purchase these on subscription. So you can scale up, you can test, you can actually have a lighthouse project, you know, and see your ROI and get it back. The third one is a fear of change. And that's probably the one that hits home right now the most here. Loss of jobs, changing attitudes, training up new staff, how it's going to work. Again, some of these are, you know, real situations that you need to deal with. I can tell you that most of the deployments, especially the ones in Germany, don't look at changing or reducing staff, but actually like training them up and augmenting their work and making the factory run a lot more efficiently.
That's a good word, augmenting. I like that.
Yeah. The second side of it is, you know, it's going to have to happen. You know, whether you're doing it for health and safety reasons, which is usually the primary, you know, driver to say, I need to do something, even if it's to put cameras up. Or, you know, later on when you're saying, I have to meet my green targets and sustainability, which can only come through better productivity and cleaner, you know, less waste. It's going to come. So the question is like how you do it and how you go across it, you know, and people think about it like as being a huge project that's going to like just eat up everything they do and change their entire universe, and it's really not like that. You know, in most cases, a system integrator will come in and do the architecture for you, and will map and will source for you and will find how to do the best way possible. They'll even define, like we do in Germany, where we'll sit down with the factory floor manager and say, where are your pain points? Where is your biggest pain point? And figure out like which technology is right. So, I mean, you know, the first fear we ever got in Germany was, don't touch my red button. You know, we said, we don't want to touch your red button. The red button is yours. Press it whenever you want. It's your red button, okay? We can help you, like make a decision about when to press the red button, or we can do something completely different that's not connected to the red button. But don't worry about that side. And, you know, we deployed there, so I mean, it's you know, there are changes happening. There are deployments like live on factory floors in Taiwan, Germany. We see France starting to pick up a lot of interest. We have in Japan, South Korea. You know, these countries are moving ahead, you know, and have got over the initial fear, and now talking about the real fears, which is like, you know, how can I secure my network? What am I doing with my network? What's the best way to use my network, and how do I see my ROI? And, you know, those are all addressable as well. I think you asked such a key question that everyone wants to answer it, because it's like the question. So I'm going to jump in as well. Generally, what we do is we take a workshop with the company that we're gonna deploy to, and in particular the people on the floor, because they're the people who've got the pain points. There are three major buckets of digitalization that can happen. One is around imaging, so that's using connected cameras. Cameras don't have to be 5G ready. They can be Wi-Fi ready, or they can be cable ready, and they can be converted with a CPE, which is a small, in some cases just a dongle with a SIM card inside, and it becomes 5G ready. So that's not an issue. The second one is around mobility, so that's talking about AGVs, drones, location services, which can happen inside. So if you want to know where a particular tool is, where a particular piece of machinery is, where a particular piece of inventory is, that can go around through there, and then seamless coverage from zone to zone. And the third way is through data, which is all the data that you're receiving from the sensors and everything that's going around it, including making a digital twin, which can then feed out into the augmented reality. These things are actually happening today, by the way. You know, a complete digital twin of a piece of machinery, and an engineer with a pair of AR goggles being able to fix that piece of machinery with expert advice in you know, being connected in real time. But let's talk about like the starting point. Basically, the starting point is usually around the imaging. That's what we find, like based on around 80% of the RFIs that we get at the end of the day. And usually around health and safety. That's the first step. Make a lighthouse project, which is like, this is the investment that's going to come in. This is the ROI I want to see out the back of it. Really important to see that there is a target, like where I'm going to make my money back. And then we sit down and we discuss the problems and what's going to be the first project. And we've had some really interesting discussions. So it's about taking a small step first, and then asking the questions and seeing how much you can do, and then where you want to go from there. You know, the biggest deployments we have, like, are running an entire factory that all connected and automated, and, you know, running through with everything you can think of, you know, like from the most futuristic ideas happening today. But usually it's like the smaller steps, the incremental steps. Once you're in, like once you put in, the camera's already there. The radio unit is usually an OpenRAN radio unit. It's there. It's going to cover that area. You can attach 30 devices to the same radio if you need to. Usually 6 to 8 is more than enough for one area. Add more units. It's not like Wi-Fi where you're adding different zones. When you add radio units for 5G, you're extending the zone. So then you're getting the seamless coverage as well. So it's an investment into the future, because all of it is software-based. 5G is a software. It's no longer, you know, cables. It's not LTE. It's not 3G. It's software. It's 100% software. The updates are happening automatically through the system. They're happening through the core, happening through the applications. It's a shame the guy who's here, like who develops apps, is gone. But, you know, even the apps are being developed, and, you know, as they're being updated, they're going straight through to the edge, and you know, being updated automatically. So it is future-proof.
How do we bring all this together? Because it seems a little bit fragmented. You know, there's a lot of different, very valuable contributions. But how do you bring it all together? Or is it already happening and I just simply don't know about it?
I think when we look at our ecosystem, we see like a complete picture. So, I mean, we usually see an SI, like a system integrator, sitting at the center. You know, they're already, you know, working with the factories that they have. They have the strategy. The strategy is coming through from the manufacturers themselves of where they want to be, some kind of long-term vision. And I think everyone's speaking about this long-term vision and how they want to get there. And then it's about building the project plan that goes with it. I think Francois does something very similar about like building that consultancy into that vision. You know, getting the government funding and you know, being able to test. I think everyone on the panel is part of the journey, and it depends where you're picking up on the journey as to which person you're speaking to at any one particular time. I think that's probably the best way of explaining it. I just want to add, like, you know, just on this technical note, there's two ways of getting a 5G network. You can either get an NSA, which is a non-standalone network slice, of a public operator. Essentially, you're getting a piece of their network, and they pretty much own the way that you get that network. And there is a risk that you're going to lose some of your traffic is going to go through some kind of public service. The second way is a standalone SA. And actually here, Britain was one of the leaders. Like, they actually allocated private spectrum, one of the first countries to do so in Europe. A private allocation means that a factory that puts in a standalone network, 5G network, owns that part of the network. It is yours. That is your bandwidth. No one can use it. No one can walk in with a cell phone and start like speaking on the phone on your network. No one can sit there and watch Netflix and suddenly your cameras don't work. It is your network. In fact, you provide the network. You tell which devices are allowed to get on that network, and what kind of qualities you give that device. So, for example, if you have a camera, you can say, I want the camera, because it's in a specific area, I want it to be on a tier 1. And because it's a camera, it doesn't need to download anything. It just needs to upload images the whole time. So I can switch that ratio around. So it's not like when I say I have 100 megabytes of data in my house. No, I have 100 megabytes at best on download and 10 on upload. You actually can switch that around and say, no, I want my camera to work in another way. And the same, you know, on the other side where you need to download the information. So I mean, you know, going on a private level, you know, I'm a little bit more passionate about this than others, but you know, I would say it's a lot more sensible, like going forward when you're thinking about like where you want to go. We believe that you know, a few years ago, the way that mobile networks went, they either went like down the route of the telcos, or they went into what's called ORAN, which is OpenRAN, which is a set of protocols that allows interoperability. Yeah, I hate saying that word. Basically, what it means is that you can connect anything to anything, like as long as you use the same protocols. It's a very, you know, technical set of documents that's constantly updated. Outside the pandemic, incidentally, we did a full deployment of a network during the pandemic in Taiwan from our offices in Israel. No one got on an airplane, not one person. So I mean that's one shock that we put behind us. But the second one, the one that's key, what's happening today? There's a supply chain issue. Okay, the biggest supply chain issue, like, you know, can be from your raw materials, but it comes down to like anything that's got a chip in it, like, is now has an issue. Being open and having an open set of protocols means that if you need 30 radio units for your factory, for example, you don't have to get them from the same operator. You don't have to wait 16 months until you can get those. You can actually say, I'll take 10 from this, 10 from that, and 10 from that, and they're all available and off the shelf and they arrive to you. So I think having that openness and, you know, being able to like be like that is really important. The second stage is like we do a lot of work, like for example with VMware and Microsoft. We can deploy, or you can deploy, our network management system from the Azure cloud, like any other app. You can download your apps that are going to run on your AI through the Azure cloud, and I think that's like future-proofing, like the way things are going forward as well. So, you know, you'll always be up to date. You'll always have the latest software, and it's, you know, always accessible to you. You know, it's just available like it would be any other app you can think about. I mean, like sitting here considering like how I'm going to sum this up. But maybe I'll tell a story. You know, like let's imagine this factory, okay? And this factory has cameras pointing down at the production floor, and it has these automated robots that are running the factory line. And it has people walking across, and the camera's monitoring to make sure everyone's wearing the correct safety and health and safety equipment. And it's also monitoring, the same cameras, is monitoring how much inventory there is for the robots on the line. It can detect that the inventory is running low for a certain point in the line. It sends a message to an AGV. An AGV then runs to the warehouse without the use of a copper wire through the floor. It already knows, because there's a complete digital twin of the inventory and where it sits and what the RFID is and where it needs to take the piece of machinery, the piece of inventory from, where to get it from, without having to get a single instruction, delivers it back. At the same point, the same cameras are now looking to see if there's any faults or issues with the machines, and the machines themselves are giving diagnostics back to the network. A machine gives a fault reading. That fault reading is then given to an engineer. The engineer is told where to find the tool in the factory to fix that particular problem, and with a set of AR goggles, then goes to the machine and fixes it immediately. Science fiction? Fact. This is a deployment happening right now in Germany, okay? Exactly as I described it. And this is what the future is going to happen. The future is happening, and it's going to happen here as well. I know it seems like a long way off, and it's hard to imagine where it's going to happen and where it's going to start, you know, and who's going to be the first. But, you know, Britain has a proud manufacturing network basis, you know. It has a history. It has a history of going forward. It also has a history of, once it's made up its mind, they're going to push ahead, and probably faster than any other country adopts. So the adoption rate might be a little bit slower, but when it happens, it will happen. And I believe the beginnings are starting to happen now. And then the question happens on what kind of connectivity you need to base your next level on. And there you need to make your own decisions. I mean, I have my recommendations. I'm happy to talk about them to anyone else. But, you know, I think the first step is to understand what you need and where you want to go and where your starting point is. And make sure it's a realistic starting point and somewhere that everywhere from the factory floor up to the board level can understand and buy in.
Okay, over to you, Nick. You got 5 minutes. Well, and the excess as required.
I'll try and use a little bit less even, but 2 questions before I start. Do we have any IT specialists, cybersecurity specialists in the audience? As expected. Second one is, does anyone know what private 5G is? Okay. So ASOCS provides private 5G management specifically for Industry 4.0 and smart manufacturing. There are a lot of advantages, which obviously I'm a big fan of, with private 5G. But one of the key issues is around security, and I've come here specifically on the security aspects of private 5G, and give a little bit of a different perspective on the whole security level. So one of the biggest things that two convergences have happened over the last few years. The first one is moving from LTE like 4G to 5G. 5G is basically taking cellular network and turning it more into a software. That's all it is. So I mean, if I once saw an advert for aluminium foil, the foil, and it had underneath it a free hat in every box. I mean, the conspiracies are out there, but basically 5G is a software. That's what it does. It delivers network at lightning speeds. That's how it works. The second one is that the cloud computing has moved into the factory or into the premise. That's edge computing. So on the one side, you have the devices, which is your cameras, your robots, your AGVs, your drones, your AR goggles, and on the other side you have the AI computation and everything you need to run in real time, and all of this is based on a 5G network, a private 5G network. Why do I insist on private 5G? Because what it means is that it doesn't belong to any carrier. There's no Vodafone, there's no O2 involved. The data never leaves the premise. From end to end, it remains strictly on-premise. No packet core goes to the public. None of it goes out to an ISP. Everything is held in-premise, and it's siloed, so that the manufacturing floor is never touched from the outside. I think siloing is something we kind of like skipped on a little bit here, but like one of the areas that private 5G figures on is that not only is, so if you have like a Wi-Fi, and someone actually manages to get the key to the Wi-Fi, they can go and surf on your Wi-Fi. They can come in, they can watch Netflix, and if they're the first one on the Wi-Fi, that's what they get. They have your bandwidth. With 5G, with private 5G, you have to actually register every single device through its SIM card onto the network, so no one actually has access to that network other than those that have been authenticated. And each device is given its own authentication across, so how much bandwidth it can take, how much uplink it can have, and how much downlink it can have, which comes to bring other advantages. For example, you don't need a camera to download anything. You need a camera to upload information. But that's not anything to do with the security side. When we talk about the security side, what we're talking about is that you have a closed loop where you are giving authorization to devices. The devices are speaking through the RAN, the radio access network, the software that we provide, and through to the edge for the computation. And all of it's done on premise and in a closed environment where you control every single part of that area. I think that basically, like, there are other areas like which are a bit more technical, like 3GPP protocols, which happen on mobile networks. Regarding on how those devices are allowed to communicate and how they're authenticated. But there's a firewall between the device and the network management system. There's a firewall between the network management system and the edge, and there's a firewall between the edge and the company data lake. So like it's becoming more and more like strict as into how that information flows and where the danger can come in and where it can be stopped. The next level of security happens like even on a level where you have the controlling unit and the distributing unit within the software, where there's going to be firewalls between those two as well. But that's a different league, and that's hopefully coming this year as well. I'm sure there's lots of questions and probably like questions you didn't know, which ones to ask. It's all new technology, but I'm happy to take